This meeting is being recorded.
Good morning, everybody. My name is Andrea Schamp, and I'm a Commercial Marketing Manager for Formulation Additives in Europe. Welcome to the last session of our first series of web seminar this year. No, that's not true. This is, of course, not our last web seminar. This is our first series. Sorry for that. Our topic today is corrosion resistance and how our dispersing agents can help improving this property of direct-to-metal coatings. To make sure there are no interferences, we have muted your phones. But we will be very happy to answer your questions via the chat function Webex is offering. The questions will only be visible to the host and presenter of today's session. It would be great if you made lots of use of this opportunity. Questions will be answered at the end of the presentation. If we cannot answer all questions, we will of course get back to you by email or phone after the session. After the web seminar, it would be great if you could stay a few more minutes and answer 5 short survey questions we have prepared in upfront. Alternatively, we will also share a link after the session leading to a survey that can be answered online within the next 14 days. Today's presentation will be held by 2 of our technical experts, Lars Hoffmann and Manfred Jorner. Lars, maybe you can start and say a few words about yourself?
Yeah, thank you very much, Andrea. Yeah, so and also from my side, a very warm welcome to our presentation about dispersing agent for DTM coatings. So my name is Lars Hoffmann. I'm technical sales manager at BASF. So I joined BASF in 2010, and I'm responsible for formulation additives or technical service for formulation additives for automotive and industrial application. So, and as I said, so thank you very much for joining. So I really appreciate so that you joined this meeting. And of course, I'm also looking forward for your questions so at the end of our presentation. So, and now I like to hand over to the second presenter, Manfred Jorner, and I'm sure that he will also give a short introduction to himself.
Good morning, good afternoon to all of you. I hope you can see me. Andrea, can you confirm?
Yes, we can see you.
Yeah.
Okay, good. I'm Manfred Jorner. I think most of you might know me because I'm for more than already 3 decades in the coatings market. I'm born and raised in the Netherlands, to be specific in Friesland, where temperatures today are far below 0. And my responsibility in the BASF Formulation Additive team is that I'm giving the technical support to our account managers and our distributors in Africa, in Middle East region, and also in the Nordics. Privately, yes, I'm a horse lover, and I'm a very proud father of a 20-year-old daughter. I would say let's get started, and as also said by Lars, looking forward for your questions and interest in the things we are going to present to you.
Okay, thanks a lot to the 2 of you. And now I wish you an interesting session about our dispersing agents for water-based direct-to-metal coatings. Stage is yours, Lars and Manfred.
Can you see my screen now at the moment or not?
Not yet.
Now you can see my screen?
Yes, yes, we can.
Yeah.
So you see the 2 beautiful guys who are your presenters of today. As we said, the topic of today is specifically the dispersing agents for water-based direct-to-metal coatings. As for sure, we have a whole package of additives that also will be shown, but the focus is on the dispersing agents Though it says improving corrosion resistance, maybe to be more inspective, having less or no impact on the total film properties in corrosion resistance. So coming to that subject, we always start with a nice overview of the portfolio package we have in the additives team. Last year, we started as a combined group of performance additives and formulation additives. We have a lot of additives in terms of dispersing agents, foam control agents, rheology control, wetting agents, and surface modifiers, and film forming agents, and at last also the performance additives in light stabilizers and antioxidants. And all these products can be used for a many variety of industries, coming from architectural coatings, industrial coatings, automotive, furniture flooring, adhesive, construction, printing, packaging, composites, and even more than is highlighted here. But the focus for today is coming on corrosion protection, specifically in the industrial application area. So thinking about corrosion protection, one can thinking about simple things like maybe interior, like steel radiators, central heating systems, like what we see today, a lot of applications coming in China in container coatings, maybe even very prestige projects like Golden Bridge, and even on our own premises in Ludwigshafen, we're using corrosion protection in our big vessel stores on the site. So there's a lot of application where a coating is required to give a good steel protection. If we're coming to that, then we see that in the coatings industry, there are a lot of drivers at the moment, ecological and social economical drivers, to fulfill all kinds of environmental regulation aspects. It starts already in the discussion with a lot of freeze. We need to be some kind of tin-free. So whether the tin comes from the catalysts in two-pack polyurethane system, or the tin comes into the water-based rheology modifier, or the tin comes maybe into the anti-fouling of tributyl tin oxide, today there is a strong drive to become tin-free. Already a longer drive is the freedom of alkyl phenoletoxylates, APO-free. Recently, more discussions, specifically in Scandinavia countries, is biocides-free. And for sure, we want to be solvent-free or very low in volatile organic compounds, VOC-free. On the other hand, there has to be also some economical benefits. So maybe we could replace multiple layer systems by one layer system. And finally, also, it should not affect the durability or the final chemical resistance of the coating in total. And for that, coming to the development of coatings, they have some basic needs. First of all, the basic needs is the materials you're using should have a global regulatory registration. So in Europe, it should be REACH, in America, it should be EPA, in China, etc. You have to fulfill the local registrations to make use of these kinds of products. It is a must-have. Then we see also in the development, specifically in the coatings, to fulfill all these regulations, that there is a longer industry standard in becoming APO-free. And in additional, we could say there is maybe differentiations between the systems in durability or tin-free or low odor, etc. And on the top level, we see there is a big change to the high solids and specifically to water-based systems. So where we had traditional solvent-based systems, we see now there is a big change to water-based systems. And the water-based systems could fulfill a lot of environmental aspects. Yeah, for sure, if you replace solvents by water, you could fulfill the VOC regulations. If you replace certain kind of toxic chemicals in solvent-based systems, you could meet by water-based systems the aquatoxicity of the water hazard class systems. And for the workers, there is this occupational safety in their health. So in the Netherlands, we call it schilderziekte, painter syndrome, like OPS, organic cycle syndrome, where people get affected in their brains by the use of solvents. We're changing from maybe traditional solvent-based systems to water-based systems. It's good that there is still a lot of things to improve. There's a big gap in performances, and that keeps most of our paint technicians a good job for the rest of their working time. Because what we compare is to maybe quick drying alkyd animals to water-based systems that the drying times can be longer. If you use solvent-based systems and replace it by water-based systems, there might be a need for preservatives, because in the water-based systems there could be a nice feedstock for bacteria. So in certain cases, biocide is really needed to keep the product stable on storage. Also, there is a gap in performance when it comes to the application window. The temperatures today in the Netherlands are far below zero, so the application of a water-based systems is not highly recommended. But it could also be that maybe at certain conditions temperatures are too high, and then also water-based systems are not suitable. So also here we see there is a smaller application window that needs to be overcome by inventing new technologies. And maybe it could also be that in the application, the paint system itself by water-based paint systems has a lower robustness in application window. Maybe the equipment what you're currently using for solvent-based systems is not good enough for application in a water-based systems. So there is a lot of development and need for improvement in these kind of application gaps. And luckily BASF has a complete product portfolio to help and to support this. For example, we have in our resin department quite a lot of water-based technologies coming from Jonquil Pro or Aconol Pro to be the base of maybe a very good direct-to-metal corrosion protection systems. For more information, our dear colleague, good colleague Rainer Erhardt can be your expert in this. But also, coming from the base of the binder systems, there is a big need for so-called little helpers. And these little helpers, these additives, can help you to prevent foam, maybe during the production, but also prevent foam during application. And foam is not required in a dry film, specifically when it comes to corrosion protection in a direct-to-metal system. Also, rheology modifiers are required to provide a certain kind of film build or to prevent sagging. Wetting agents, substrate wetting agents or surface modifiers are required to give very good substrate wetting, and by this, for very good substrate wetting, maybe adhesion can be improved, or by having a very smooth surface, also the protection of the coating is improved. Finally, some film forming agents to get to a good coalescing or to maybe early water resistance. And also, when solid particles used on a liquid media, the so-called wetting and dispersing agents are required. And here the dispersing agents should have low or no impact on the total final film when it comes to corrosion resistance. And in corrosion resistances, we have different kind of classes according to DIN and ISO. So the lowest class in corrosion resistance is the C1, and the most toughest class and difficult, highest protection class is the C5 class in corrosion resistance. So a C1, C2 class, one could thinking about maybe the coating of central heating systems, and really a C5 class could be the protection of a oil platform somewhere in the sea. And coming to the water-based systems, direct to metal, at the moment we can fulfill the classes C3 to a C4 medium. So when changing from solvent-based systems to a water-based direct to metal, choosing the right binder systems, having the right additive package, a C3, C4 class corrosion resistance is possible to achieve. And one of the components we would like to highlight today is the dispersing agent. And why do we need a dispersing agent? Well, if you're using organic, inorganic, or active pigments in a water-based media, then a wetting dispersing agent is absolutely required. For the organic, inorganic pigments, it helps you to improve the color strength. It could even help you to improve the color acceptances if you're working from colorant systems into the water-based systems. It could help to improve the storage stability, no settling, no sedimentation, a constant rheology, so easy pumpable. It could help you in the production of the color concentrates in having a very low mill-based viscosity with a very high pigment load, a more Newtonian rheology behavior, so it's free-flowing, easy pumpable, and finally, it should not have an effect on the total gloss system of the system. And on top of it, specifically in the water-based direct-to-metal, the dispersing agent should not have an influence in the final film properties, moreover into the corrosion resistance. So if you have a very good protective coating systems, the dispersing agent should not have a negative effect in the total corrosion resistance or the water humidity or in the salt spray tests. And here we have done a lot of studies. And in this case, I would like to switch over to Lars Hofman, who has done with the lab team quite a lot of studies in testing the different kinds of dispersing agents, where they have an impact or no impact in the final corrosion resistance of the coating. Lars, I give the ball to you.
To leading so the results. As already said, so dispersing agents are needed.
Lars, sorry to directly interrupt, but could you come a little closer to the microphone? I know we changed this setup in between because we had the feedback that it didn't work so well, but it actually is worse now. Sorry for that.
Yeah, so can you hear me now better?
A little.
A little. Okay. Yeah. Sorry for this.
Or you put the headset back on. Is it good, the sound? Okay, I get the feedback that it's good. So then move on. Yeah, sorry for that. Okay.
Okay, so then if it's now better, so then I can continue. Hopefully you can hear me well. Yeah, dispersing agent needed, yeah, so to achieve storage stability, color strengths, and so on. And what every formulator is expecting that the dispersing agent should have not strong impact on the corrosion resistance, and therefore, so we did, as Manfred said, so some studies to show, what's happening. Yeah? So by using dispersing agent in different formulation, and for that, so we selected two different cases. The first case is based on guide formulation based on German-Cool Pro 1522. So it's a formulation for a DTM application. So, and we tested different dispersing agents, but so the one so I would like to highlight today, so in this regard, is the Dispex Ultra PX 4575. It's a block copolymer polyacrylic-based dispersing agent. So it shows very good performance for inorganic pigments and fillers. And it shows also very good compatibility to different binder systems. So, and this was the reason why I selected this one, so in this study. As I said, so we selected guide formulation based on the John-Cool Pro 1522. As you know, so this dispersion is acrylic-based binder system. And so you see on this slide, so the guide formulation, so we made a direct grind, water-based titanium dioxide slurry, you can say, where water, dispersing agent, wetting agent, defoamers, ammonia, and the titanium dioxide. So then grinding and taking care that the Heckman gouge or grinding is less than 10 microns. So, and then we add the dispersant into the formulation, completing, so with some other ingredients. So, and values for the specific formulation you see here with a VOC content of 200 gram per liter and with a solid content of 47.8. So, and we tested different dispersing agents. So, and in comparison to the second case I will show you later. So we selected more low or medium molecular weight dispersing agent, and so with a 4575, a polyacrylic high molecular weight dispersing agent to see differences. You can also see that the chemistry of the different dispersing agent are different. So with the dispersing aid, we have phosphoric ester ethoxylate with dispersing B, an ammonium salt of a carboxylic acid. Dispersing C is a polymeric one. And we made different tests to show what's about really the salt spray test and the humidity test. So therefore, this is often the balance you have to find out if it comes to humidity resistance and salt spray resistance. So often it's necessary to balance both to achieve with both test methods the optimal performance. And now on this slide you see already test results of the salt spray test on cold rolled steel. And so you see on the left side, dispersion A, B, the Dispex Ultra Peaks 4575 and dispersion C. And you see the results of the salt spray test after 48, 120, 144, and 168, 216, and 288 hours. And you see easily that with the Dispex Ultra Peaks 4575, we achieve by far the best corrosion resistance in this testing. As always, sometimes it's easier to see results also on pictures. So therefore, we prepared pictures of the panels we tested. And again, also here, you see easily that with the Peaks 4575, that we achieved really the best their best corrosion resistance in the salt spray test. Here we have the results after 120 hours. You can also see that, okay, so there with the dispersion B, for example, a very bad one, but also others are not so bad, but again, the Peaks 4575 is by far the best one. Now I will come to the water spot test and condensation water test. So maybe some words about the water spot test. Here it's quite common and easy testing. You put some milliliter of demineralized water on your panel. So and then you put a glass dish on top of that. So and after 24 hours, you make some adhesion testing and then to see the differences, and also after 24 hours after exposure, that the film is dried, you also test it again, and also there you can see in some cases a huge problem. In this case, you see at the beginning this is often the case. The adhesion is not perfect, but after 24 hours after exposure, you see that the good adhesion will remain. With the condensation test, you also see differences, but really slightly, or not, you can say no differences. So therefore, you can say all dispersing agents have no real impact on the condensation test. So and with the gloss, you see also some differences, but depends on the application. So maybe this is not depends on formulation. The gloss of the formulation, this is not in the target. Coming now to the second study, as I said, we selected different dispersions for this, and in this case, we selected the Acronal Pro 770X This is a relatively new dispersion version, and it's also recommended as an acrylic dispersion for DTM application. So, and in this study, I'd like to highlight the Dispex Ultra PX 4290. This is also high molecular weight dispersing agent. And so especially this dispersing agent shows a very unique or universal character in regards to inorganic as well as in organic pigment. It's a solvent-free product, and it has an active content of 40%. So this is a test formulation we selected for the testing. Also a grinding with a titanium dioxide slurry, then adding the dispersion, and then completing with the deformer, corrosion inhibitor, and rheology modifier. So in this case, especially, the PU 1191 is the preferred PU rheology modifier. So for the best performance and then the best efficiency. So to control the rheology behavior of your formulation. Also in this study, we tested different dispersing agents, and you can summarize that most of them, they're really high molecular weight dispersing agent. And here you see again, in addition to the PX 4290, you see also that we add the PX 4575 to this study, and also here we made a corrosion test according to the salt spray test, also humidity testing in the cabinet. Also, we made some rheology measurements or investigation to see the differences. And with these rheology measurements, I would like to start. So what we'll see here is that all formulations shows a very strong pseudoplastic flow behavior. But the differences are not so huge overall. Also, the gloss level was on more or less the same level. So you see minor differences in the gloss level with a measuring angle of 20%.
Lars, I would like to remind you a little bit of the timing.
Yeah.
Thank you.
Thanks. So photos on cold rolled steel. So coming now to corrosion results. And here you see that, with the Dispex Ultra PX 4290, we have really the best corrosion resistance we can achieve, in this test series. With all other dispersing agents we tested, we saw minor, but in some cases bigger differences, as you can see, especially on the right side with dispersing agent 4, for example, really strong red rust formation. And we also see, with a PX 4290, lowest rust creepage. So to complete the build, also the pictures of the second series of dispersing agents with 4575 and the other ones. But I must say, also in this study, the 4290 was the best one. So a special benefit of the 4290, the PX 4290, is that this dispersing agent is suitable for epoxy formulation, because you can add this. This dispersing agent shows no interaction with an epoxy resin. In this case, with a water epoxy 1455. So this is maybe in some of your application necessary to know that with a 4290, that it's also suitable to make a direct grind in the epoxy resin, because with a 4275, So this is not suitable because you see, so after 1 week at 50 degrees, that reaction starts, and this leads really to a solid. So this indicates that the 4575 is not suitable. So the first choice for us for epoxy, water-based epoxy formulation for DTM application is really this big Ultra Peaks 4290. So, and therefore I like to summarize, so this overview of dispersing agent for anti-corrosion systems. So we have two dispersing agents we like to highlight for this application. The Dispex Ultra Peaks 4575 is preferred for acrylic dispersion. I showed you the results with the John Core 1522. And so the Dispex Ultra Peaks 4290 is also suitable for acrylic dispersion, but also suitable for epoxies. So, and in this table, you also have a good overview, so which dispersing agent is suitable for the specific resonant dispersion. So for your application. So therefore, Dispex Ultra Peaks 4290 shows a more universal character in regard that this is also useful for epoxy. So, and this would be my part, so also presentation. Thanks a lot, for your attention, and I like to hand over again to Andrea.
Thank you very much, Manfred and Lars. I would like to give you some insights in our Solution Finder tool for formulation additives, covering all industries regarding formulation additives. That means it is a guide for paints and coatings, but also for adhesives and construction, giving an overview on the benefits of all our technologies, be it dispersing agents, defoamer, rheology modifier, wetting agents, and surface modifier, and also film forming agents. And you can order samples by email and consult us for detailed specific information. Our lab assistant is mainly directed towards architectural coatings, including formulation additives and dispersions. You can get product recommendation, also formulation ideas. You can ask for all relevant data, be it MSDS, TDS, and so on. You can also compare products or formulations and also get in contact with our experts. And with that said, I thank you very much for your participation in our web seminar today. We will collect all your questions and come back to you after the web seminar. As I said at the beginning of this session,